Hey guys, Lucas from JangaFX here, and today I'm going to be showing you how to make this awesome looking whirlpool in IlluGen and then porting it to Unity. We will be creating the effect from scratch all within IlluGen, and then export the textures and meshes to be used in Unity. We'll then use Unity shader graph to create a shader to get the end result that you see. Alright, so here in a new project in IlluGen, and we're going to get started on this whirlpool. So the first thing we want is to get a disk on the screen. So the easiest way to do that is just to use the GeoShapes node. And the GeoShapes node creates geometry procedurally. You have a ton of different shapes you can choose from. And in this case, we just want the disk. And you can see here, we have the disk here. Now if we double click our render, you can see that our disk is not being applied here. All we need to do is just drag the geometry pin from the GeoShapes into the renderer geometry pin. And you can see our shape is now there. And let's throw a bit of color on this guy. So to do that, we can get a fractal node. And the fractal node is just a really powerful noise node. Nick has a full video on this guy and all its capabilities. So we can plug this in the albedo by first going through a color ramp node. This basically converts our grayscale fractal into a color output. And then we can plug that in our albedo and we can see it applied to our disk. Now we're seeing a few triangle artifacts here, and there's a good reason for this. The GeoShapes disk node actually has its UV coordinates in polar space. And what that means is the x-axis, rather than going, x along the grid and then y along a grid straight, the x-axis rotates around the disk and the y-axis goes in and out towards the disk. And this will be really important for our whirlpool effect. But what we're seeing here is we just don't have enough geometry to represent the effect in total within the UV coordinates. So what we can do is just add more geometry and that will fix the problem. The easiest way to do that is radius subdivisions. We're just going to throw that all the way up to 200. And then for cap subdivisions, we'll also go all the way to 200. And we're going to have a lot of geometry on our disk. When we come to exporting this into Unity, we're going to be playing around with the number of subdivisions to get a nice balance between quality and number of triangles used. And you can see there now that our disk doesn't have those triangles anymore. So now we want to animate this fractal along the disk. And the best way to do that is to just move the UV coordinates. So we can get a GeoUV node. And what this does is basically modify the UV coordinates of the incoming geometry in all different sorts of ways. So in this case, we are doing a planar projection. You can see we were a circle before, and now we're just kind of like a basic grid. What we actually want to do is do keep current. And that means keep the existing coordinates, and then let's just do a few modifications to it. In this case, we want to modify the UV offset to basically move the fractal pattern on the disk. And we can do that in the UV offset parameter at the bottom. We have the X. Now remember, this is polar coordinates. So X will rotate around the disk. You can see as I move the X, it rotates. And then Y will move in and out to the disk. So if I plug that into our geometry node, and I double click our renderer, if I just click once on the GeoUV, I can modify the UV offset here manually. And you can see our fractal pattern going in and out as I scroll it. And so to animate this, a really easy way is to click this little circle on the left. Clicking it once will do timeline override and you'll get a diamond shape. And then you could put keyframes in the timeline and animate it that way. What I'm going to actually do is click one more time and get pin override. This adds this extra pin here called UV offset, and we can drag it out and plug it into a modulator. And I want mod cycle. And cycle just basically cycles this triangle wave until the end of time. So it'll basically animate forever when the timeline is playing. So if I click play now, you can see, whoop, there, our guy go. So what we want to do is two things. One, we can see that it's animating, rotating, and going in. We just want it to go in. We don't want it to spin around right now. So in the mod cycle, we can do mode 1, which is the x-axis to none. And you see it's flat line here. Now we're just going in. And you can see on our mesh the fractal going in, but it's going a little bit too quick. So let's just tone it down. Let's just try 0.2. You know, that's looking a bit better to me. Cool. So we got the base of our mesh here. Uh, but with a whirlpool, you know, it kind of swirls in, it rotates around as it goes towards the center. So to achieve that, there are a ton of different ways you can do that in IlluGen. In this case, I'm going to be using the geo-combined transform. And the geo-combined transform, it's a big name, but basically it lets you modify the positions of the vertices based on some parameters. So I'm just going to plug this geo-combined transform into the geo-UV, and then we'll get started. In this case, I want to modify the rotation of the vertices based on how far away they are from the center of the disk. So in gradient index source, I can use distance to point to achieve that. And basically our modification will occur based on how far away the vertices are from this point. And I could move the point around, but I just want it to be at 0 for 1. Then in the rotation parameter, I can put that value up and you can start to see it swirl around the center. So I'm just going to plug in 360, so it's going to do one full rotation as it comes in. And now if we look at our renderer, we can see now we're getting that swirl that we want, which is looking really good. Another thing whirlpools do is usually they go down as they swirl in. So we can still use the geo combined transform, and we can use the translation. So if we put the Z, which is up and down here, we can move that up, and you can, if I go under the grid here, you can see that it's starting to push, creating a cone, right, for this swirl going down. I'm just going to turn off the grid view here, just because it's going below the grid. So we're having this swirl come in, but it's looking a bit flat. We want it to be a bit more three-dimensional. So what we can do here is we have the geo UV, and we have a node called the geo displace node. If I can find it, here it is. The geodisplace node is basically going to displace the vertices based on the height map. So the more white the height map is, the more the vertices will go out. And the darker it is, the more it will go in the opposite direction. So if I get the fractal here and I plug it into geodisplace, you can start to see it's already got like a pretty immediate effect. And I'm just going to plug this right into our renderer so we can see it there. And the geodisplace, we can modify the range here. And I'm just going to tweak this around till I get something that's looking pretty, you know, there's a lot of texture, but it's not over the top. And if I play the timeline, you can see that's looking pretty cool. Let's just move the sun around, maybe move it a bit higher up so I can see. Yeah, cool, okay. That's starting to be what I want already. So we'll just use that as like a base layer. And let's add a bit of color to this guy. So the first thing we're going to do is, rather than plugging this into the albedo, this color ramp, we're going to plug it into the emissive to make it glow, basically. And then with the albedo, I'm just going to make that into like a flat color. Let's make that like a kind of dark, dull blue, something like that. Then with the color ramp, I can start tweaking the values to basically get the highlights on the peaks of the whirlpool here. So to make it a bit more magical looking, I'm going to use like a turquoise kind of color at the top here. Maybe in here we could have like a nice purple kind of, I'm going to make it quite soft looking here. And I'm just playing around with the parameters. And then something I always like to do, especially with these kind of effects, magic ones, is add a lot of like, kind of like a little explosion in these dark bits that will pop up here and there. So to do that, we can add a really bright green into the dark areas there. And we don't want too much, we just want a little bit, right? And if we play, you can see we've got those dark areas there. And to make this stand out a bit more, we can boost the emissive intensity in the renderer node. So if I put this to 25, it's going to be pretty bright right now. And so we want the brightness in these green little explosions, but we don't really want it in the kind of pink purple area. So we can just go into our color picker and we're just going to put the value down to be a little bit more to what it was before. And the same with the cyan here. Something like that's looking a bit better to me. And to make these green bits stand out even more, if we go to our renderer node, we can add a bit of bloom just to make them glow, and we get a bit more of a sense that they're really bright. And that's looking really cool. The next bit we want to do is, I kind of don't want these to just remain static, these green little bits. I kind of want them to come in and out, kind of like an explosion, right? So the easiest way to do that is in the fractal node. We're just going to click this 3D noise checkbox. And this is basically going to let us animate on the Z axis the fractal node here. And you can see as I'm dragging my mouse, the kind of effect, you can see it's kind of wobbling, morphing around, coming in and out. And it's looking really cool. So to animate it, we can just do the same thing we did with the GeoUV, with this UV offset mod cycle. But this time, we'll just plug it into the Z position. And we'll click once for timeline override and we get a diamond. And we can click again for pin override. And then we'll just take him out and we'll put him in a modulator cycle node. And you can see he's starting to go in and out. Now I'm just on a small MacBook here, so starting to lose a bit of frame rate because the fractal node is quite expensive. If you're on a discrete GPU, I'm sure you can run this no problem. So I'm just going to put the texture size down to 512 just so I can work at a high frame rate like you see here. Now this mod cycle is going a little too quick, so let's kind of tone him down. Let's try 0.3. Maybe even slower. Yeah, 0.2. I kind of like the amount of time those green kind of explosions come out for. Cool. So this is kind of like the base of our whirlpool effect here. But we're going to do some interesting tweaks to the lighting here to kind of make it look a little more magical and kind of push the IlluGen renderer to get a cooler look, basically. And a trick that I found is in the renderer, in the ambient color, we can make this ambient color really, really bright. And so I'm just going to put in a bright blue and a ton of intensity. And it's going to look a bit absurd at the start. But what we can do is in the fractal, we plug this into a levels node and we put this into the ambient occlusion. And ambient occlusion is basically, it's going to say when it's dark, don't use any ambient color. And when it's white, use all the ambient color basically. And so we're just going to kind of crush this texture a bit. So just like the bright parts here, we just want the ambient color to be more on the peaks. Something like that. Now, we don't want, right now it's being kind of uniformly applied because we don't have any roughness texture applied. And the roughness will basically make it more shiny or less shiny based on the value of the texture. And then we can kind of achieve a rim lighting effect using this roughness. So with our fractal, I'm going to put him back in another levels node. I'm going to plug this into the roughness. And you start to see we got this like rim light here. And what we want is we want it to be really soft, the rim light in the dark bits. And then we want it to be more harsh on these peaks here. So the way to do that is with roughness. Black means not very rough at all, and so it will be very shiny and have a lot of rim light, while white means very rough and not much rim light at all. So really what we want to do is flip this texture, kind of invert it upside down. I shouldn't say upside down, invert the values. So black becomes white, white becomes black. And then just like the ambient occlusion, we can kind of crush the values here to kind of get what we want. And I don't use pure white, I just kind of want to tweak it. And then here we can just kind of like tweak the values a bit around to try and get something that we like, you know, visually. IlluGen is more of like a pre-visualizer in here because we're porting this to a game engine. The colors and the exact end result's going to look a little bit different. some things you can do in IlluGen you can't do in your engine, and some things in your engine you can't do in your IlluGen. So being really experienced with your engine of choice will let you kind of use IlluGen to its full power. So I'm just going to play around with the colors here for a second. Okay, that's looking a bit more like what I want. Just going to tweak the colors balance here. That's something we could put in our game engine pretty easily, I reckon. And I'll show you that right now. I'm just going to clean up the graph here a bit. I'm using auto align, so you can right click and then you click align or auto arrange. So I'm using auto arrange option A on Mac, and I believe it's Alt A on Windows. So when we're exporting this to the engine, there are a lot of things we need to consider. Are we targeting a mobile game? Are we targeting a console like the PlayStation 5? How important is this effect? Is this like a hero effect, or is this something just going to be chilling in the background, right? So that will basically change our strategy when we come to export. I'm going for like kind of like this is going to be pretty large whirlpool effect that you're going to see on screen, but I don't want to throw too many triangles at it. The first thing we're going to do is export the mesh, and then we'll do the textures. So the mesh, there's a few things we need to consider here. The biggest thing is if we go to our GeoDisplace node, you'll notice that all the normals are correct after we displaced. This is because we have this recompute normal ticked. If I untick it, you can see the normals look a little different. They don't look as accurate as they were before. And this is what we see on our mesh. It actually kind of looks pretty cool in a stylized sense, so maybe this is what you want for your game. But with the effect I have in mind, I kind of want to reconstruct the normals. So this recompute normal is usually not just present in engines out of the box, at least not in Unity that I'm aware of. So I'm going to be reconstructing the normals from the height map. And to kind of preview what that looks like in IlluGen, we can just take the fractal node and we can plug it into a normal create node. And then we throw that into the normal, and let's just increase the strength, and we regain most of the kind of 3D look. It's a little more noisy, but I actually kind of like the extra noise that it creates. It kind of adds a bit more magic to it. I actually kind of prefer it in a sense to recomputing, and if I were to remove that. So sometimes it's kind of a win disabling things and seeing how it looks doing it in a different way. So we know we're not going to have the GeoDisplace node, and we also know that the UVs, we're just going to recreate this in our shader, this mod cycle, which is basically just adding a number to the UV. So really all we need to do is export this geo combined transform. So a few things we need to consider before exporting. In this case, we want to go down, and in this topology soft edge angle, we want this at 180 degrees. This means no edge splits will occur within our mesh, and everything will be really smooth when we import it in Unity. So we can put that in an export node. We also need to consider the amount of geometry we're using. If you remember, we just put the number up really high just to get started with the effect. But now it's time to kind of dial it back down and kind of have a nice balance between number of triangles and quality. So first thing, let's do topology triangles, because that's what we're going to be using in our engine. You can see right now it's at 80,000 triangles. If this was maybe like a hero effect, like this was going to fully fill your screen and there's nothing else, 80,000 triangles, that's totally okay, right? But if this is just in the background, maybe we want to use a little less. So let's just tweak the subdivisions while the animation is playing, and we can kind of find out what's a nice sweet spot. So first I'm going to do radius subdivisions. And as I pull that down, you can see we get a bit of loss along the edges here. I'm on a really low number, 10 right now. But, if I go to around 50, there's not much difference between 50 and 200, especially when it's animating. We just lose a little bit of like fidelity, but I feel like we get a lot of savings here. We went from 80,000 triangles just to 20,000 triangles like that. And then now let's look at cap subdivisions too. So as cap subdivisions go down, we can see that, okay, that's a bit more important, the cap subdivisions. So maybe we want more cap subdivisions versus radius subdivisions here. So let's say 100 cap subdivisions. That's looking pretty smooth still. If I just pause and see the difference, there's not that much difference. And now we're down to 10K, so we're 8 times less triangles for, I would say, basically in motion, the same kind of quality perception. So I think that's a good number of triangles to do our effect with. So I'm just going to export that with the export model. And now let's start exporting our textures. So all our textures here are generated from this one fractal. So we're going to actually recreate all of these within the shader with just some really simple math. So all we need to do is export the fractal node. So the fractal node is being animated by the Z position. So how are we going to animate this in the game engine? Well, one way to do it, which we'll do, is using a flipbook, which is basically saving out the fractal in different frames, and then we're going to replay it in engine and blend in between. So in this case, I'm going to have 4 frames, and because this is such a simple example, it's actually kind of easier just to copy and paste the fractals temporarily rather than creating some sort of automated setup. And we're going to manually do the Z positions here. So I've just turned off the timeline animation for Z position. So we have 4 frames with the Z position. 0 and 100% are the same thing. So you can see as I go between these two, there's no difference between them because it's perfectly loopable. So what we need is to do 100 divided by 4. No, and that's how much we increase the Z position per frame. So 100 divided by 4 is 25. So do 0%, 25%, 50%, and then 75%. Now we could encode this using the sheet encode node. And the sheet encode node basically does like a flipbook for us. But in this case, I just want to bake these all into a single color texture in the red, green, blue, and alpha channels. So our first frame goes into red, second into green, third into blue, fourth into alpha. And now we have this beautiful looking tie-dye rainbow texture. And we're just going to export this too with the export color node. And I'm just going to put this height map at the end here. Now we've got to remember to untick sRGB texture because these are linear grayscale height maps that we want to export and not sRGB colors. We also want to check export alpha to ensure that the alpha channel gets exported too. And now we click export now and our height map has been exported. The last thing we want to export is this color ramp here. A really easy way to do that is just to plug it into a gradient node. So if I find him in grayscale gradient, and this is just black to white, left to right, and you can see it creates a nice little gradient texture for us. Now we don't need this super high Y resolution, so temporarily in the project, I'm just going to set the height to 1 pixel to get a nice thin texture. Now we're going to export that using the color node. And this time we are going to use sRGB texture because this is a color texture and not height information. I will name it gradient. And then I hit export. And I believe all my assets are ready to be used within Unity. I have Unity now open up, and I've just dragged in our assets that we created in IlluGen and put it in the scene. So a few things we need to do before we get cracking. With the height map texture, we need to make sure that we untick sRGB color texture. If you remember, this is linear height map. Now for the gradient, we also want to disable generating mipmaps, and we don't really want texture compression. This is such a small texture that doesn't really benefit from it. I'm going to create a new shader graph, and I'm going to call it Magic Whirlpool. So now I have my Magic Whirlpool graph here. We can start porting the effect from IlluGen into Unity. And we can actually add a few extra things that we could not do in IlluGen. So the first thing we want to do is probably recreate the displacement. And that's really easy. We can just use the vertex shader here to displace the mesh by its normals. So to do that, we need to do a few things. First, we need our height map. So let's create a texture 2D. We also want a displacement strength. Let's use a vector 2. We'll call it displacement intensity. We bring our height map in, and bring our displacement intensity in. We also need the normals from geometry. We also need position from geometry, and make sure that these is set to object space and not world space, because the vertex shader is expecting it in object space. So to displace, we can sample our texture using sample texture 2D LOD. We need to use the LOD for the vertex shader. We then get the red channel and we can multiply that with the normal vector. We can then add it to the position. Now, when we connect it to the vertex, we should see some displacement going on. And to get some more intensity, we are going to use the remap node. And we're going to remap 0 to 1 to our displacement intensity. And we've got to make sure we plug it in. In IlluGen, I used the values -5 to 7.5 here. And now we can start to see some displacement. Now we want to animate it. Let's get the time node. And we'll plug this into a vector 2 node for the y coordinate. Remember, we want to scroll along the y. We can then add this to the UV coordinates of the geometry and plug that into the UV sample texture LOD. And you can see it's starting to swirl in. We probably want a speed value here. I'm going to call it swirl speed. We can just multiply swirl speed by time to control how fast this animation occurs. Now we have a little bit of pinching in the center of the whirlpool here. You can see right here. And this is because we have geometry clipping near the center here in this pinch point. So the way to fix this is we're just going to have less displacement the closer it is to the center. We can do this really easily using a bit of math. Let's just get our position and we'll split it and get the XY coordinates. We're then going to use distance and we're going to remap it. And then we'll saturate. And then we'll multiply our displacement by the saturated value. Remember, saturate is clamped between 0 and 1. So I use this remap node here to basically change the distance at which it stops displacing. And you can see right here in the center, it's no longer displacing. We can kind of tweak it to get the exact value that we want. And before we continue, I'm just going to shrink this guy down because he is quite large. I'm also going to set cast shadows to two-sided so we get proper shadowing. Now we want to start unpacking this flipbook. Remember that we have one frame in red, one frame in green, one frame in blue, and one frame in alpha. So how are we going to unpack this? I'm going to make this really easy using a subgraph. And the reason why we're using a subgraph is so we can reuse it in multiple places in our shader, because we're going to be doing this in the fragment shader and also here in the vertex shader. So do create, shader graph, subgraph. I'll call it flipbook 4. Let's open it. Our output is going to be a float, and we're just going to call it height. And we're going to have 5 inputs, all going to be float. The first we're going to call frame 0, frame 1, frame 2, frame 3, and this will be time. With our time, we want to get fractional, because we want to have the fractional part, so just between 0 and 1. We're going to then multiply this by 4 because we have 4 frames. Now we're going to use a bit of math to blend between the frames using this 0 to 4 value. I'm going to use this by using saturate and lots of subtractions. So we have 4 frames, so let's get 4 saturates out. And we want 3 subtractions. Each subtraction will plug into 1 saturate, and the multiplier goes into the A of each subtraction. So we're going to subtract 1, subtract 2, and subtract 3. We could have a subtract here, but it'll just be subtract 0, so it's not necessary. And to see what this does, we can just plug in an actual time node here. And you can see it has this staircase effect, where it's going to go white here first, then it's going to go white there, then after that's white, this will go white, and so on. I'm going to use this to blend our inputs. So the first saturate, we're going to do a lerp for the T value. And we're going to lerp between frame 0 and frame 1. Then the second lerp, then we're going to create another lerp. We're going to plug the first lerp into A of the second lerp, and we'll use the second saturate as the T. Then frame 2 will be used as the B value. We're going to do this again. We're going to plug in A into the lerp. We're going to use frame 3 this time for B, and we're going to use the third saturate. We're going to do it one more time, This time, the third lerp goes into the fourth lerp A, last saturate goes into T, and we'll loop back to frame 0, creating a perfect loop. This will be our output. Now back in the main shader, we can get our flipbook 4 subgraph, just drag it in, and we can plug in the red, green, blue, and alpha channels to have it animate. And remember, we have the time node still in there, so if I go in, we actually want to plug this in here, and we want the time node out here because we want to modify it in our main shader. So we plug time in, and we use this for our remap. We're going to get that warping morphing effect back in our main material. And to visualize that, we can set the swirl speed to 0. You can see it morphing there. Let's create a variable for the morph speed. I'm just going to call it morph speed. And we're going to multiply this with time and plug that into the flipbook. And we'll use this for everywhere else in the graph. And that is our vertex shader completed. Let's start working on the fragment shader. First thing we want to do is to get our gradient in. So let's create a new texture. Let's call it gradient. Let's add an intensity multiplier, call it gradient intensity, and we're going to plug this into a sampler. And this time we're not going to use LOD. We're just going to use the regular texture 2D. We're going to plug this into our flipbook 4 and make sure we get our morph speed into the time here. And we'll plug this directly into the emission of the fragment shader. We should actually be plugging in the height map here into the sample texture. We're then going to plug this into another sampler in the UV coordinate. But we want to make sure we only sample on the x-axis. So we plug this into vector 2x. We also need to make sure, I forgot this at the start, we set the wrap mode of our gradient to clamp. We'll multiply the output of the gradient with the gradient intensity, and we'll put that into the emission. Now, to make the gradient also follow the UVs, we just need to take the UVs that we use for the vertex shader and plug it into our sampler. Unity sometimes won't let you plug things in across vertex to fragment shader. A workaround I've found is to just plug it into a preview node, and then the preview can go directly into the shader node that you want. And you can see here now that the texture swirls into the center. All right, so now let's get this sheen a bit in control and the ambient light. So what we want to do is, if you remember, we use kind of a dark blue for the albedo, the base color. Let's just plug in something similar. Look like that, I think. Maybe go a little brighter to get a bit more of the sun involved. And now we also want to do the remapping for ambient occlusion. So we can get a remap node, plug that into ambient occlusion. I'm just going to tweak the values here to get something that I like. Make sure you saturate the ambient occlusion before plugging it in. This clamps it between 0 and 1. We're going to do the same thing for the smoothness. Unlike IlluGen, Unity uses smoothness and not roughness. So black is not very smooth, so it's very rough, and white is very smooth and not very rough. So it's basically the opposite of IlluGen. So I'm just going to dial in the values here. Let me just turn the sun to see if I can find, yeah, there's the sheen that we're talking about. All right, let's recreate the normals using the height map. The easiest way is to get 2 more sample texture nodes with this flipbook. Go 1, 2. The only difference is we'll add a little offset to this UV. We'll add a new variable, we'll call it normal offset, and we'll plug one into a vector 2x, and we'll plug into another vector 2y. We'll then add this to the UV, and then the x will plug into one sample texture, and the y will plug into another. We're basically going to use this XY difference to calculate a kind of guess of what the normal should look like. Easiest way to do that is to subtract the values from the original height map value that does not have an offset. We're then going to add a new variable called normal intensity, and we're going to multiply these 2 nodes by that. We're then going to plug these into a vector 3, both into the z-axis. For the node using the x offset, we're going to set the x to 1, And the node chain using the Y offset, we're going to set Y to 1. We're then going to get the cross product between these two nodes. And you can see we kind of have a tangent looking texture here. Then normalize this and plug this into the normal of the fragment shader. The offset you use should be a really small amount. Right here, I'm using 0.05. You kind of want between 0 and 0.1. You don't want to use more than that. Play around if you really do want to. It's up to you though. So we reconstructed the normal. We have the emissive. We kind of got everything we want. We just need a bit more glow. Remember that rim lighting we had? We're going to do something like that, but something even cooler in my opinion. So to do the effect, we need to get the world space normal from this height map. And the best way to do that is to get the normal of the geometry, the bitangent of the geometry, and the tangent of the geometry. I'm just going to do a bit of math to basically convert this into a world space normal. With our normal map texture, we're going to split it into the red, green, blue channels. The normal vector is going to multiply with the blue. The bitangent is going to multiply with the green. The tangent is going to multiply with the red. The specific colors you use to do these multiplications do depend on what engine you are using. We're then going to add all these together. And you can see here the preview, our normal map is being applied. So what we want to do is then do a dot product with the current view from the camera. We'll use view direction. And this is creating some sort of, if I plug this into emission, we can see a kind of mask. Oops. Should go in emission. You can see it's dark here. And then when we're looking at head on, it's white. A cool effect you can do with this, I found, is to actually invert it and then run it through two power functions. So first we're going to saturate it so it's between 0 and 1. We're going to do a 1 minus so it flips. We're going to run this through a power function. We're then going to invert it one more time and we're going to run through one more power. We're then going to add a variable. We'll call it glow modulation. Make sure this is a vector 2. We're going to split this vector 2. The x is going to go into the first power and the y is going to go into the second power. We'll then plug this into our emission. If you're seeing pink or some other weird colors here, the reason why is probably because your glow modulation has a default value of 0. You just change it to 1, you'll get some color back that looks a bit normal. And if we tweak this inside our shader, I like to use for the X kind of a really small number. You can see it's kind of glowing, creating a subsurface scattering almost look in the back. And then for the Y, you can kind of then further control the spread in an interesting way. So we'll just do 0.05 and let's go 1.5. We'll boost these values up in a sec. Let's add a glow color and let's add a glow intensity. The color is a color variable and intensity is just a float. We're going to multiply the color with the intensity and then we're going to multiply that with the end result of our powers. We then plug this into emission. We'll then be able to control how strong and what color the glow will look like. So let's do like a kind of turquoise color and let's do intensity of 4. Now I actually want to animate this intensity here. So let's go back in. Let's get a time node. Let's add a new variable called glow speed. And let's change our glow intensity to a vector 2. So I think we have to delete it and add it again. With our time node, we're going to multiply the time by glow speed. We're then going to run that through a sine function to get a wave. We're then going to remap our sine function, which goes from -1 to 1 to our glow intensity. We're then going to use that remap to multiply our glow color. So now you can see here it glowing back and forth, but we just need to add our gradient back in. So we go to Magic Whirlpool. Let's just add our glow color to what our gradient does, and we'll plug that into emission. And then we get both of them combined. And now we're getting a really sweet looking effect here. I'm just gonna tweak some things around until I'm happy. Okay, I've kind of set up the colors and the speeds that I kind of like. It's looking real awesome now. Just for visualization here, I'm just going to set my shader to render both back and front. Not that it's very necessary. It just kind of lets you look underneath and see what it looks like. You can even, flip it upside down and still looks pretty awesome.
I've done a few little tweaks here with the normal offset, and I'm really happy with the end result here.
I'd be super stoked if this was in my game. I hope this has been helpful, guys, and I will see you in the next tutorial.